Hi, the 7.4 ordinal multinomial responses. So we have introduced several models, and here we consider some alternatives. So we don't have the R code and the not specific the examples, but certainly these are important to consider when you do practical analysis. So first is the linear model. So the ordinal variable has the more value than, for example, the binary variables. So suppose that this is the predictor and the y is response. And okay, so suppose the y has only 5 levels, but still it makes some sense to fit the linear model. So suppose the data is like this. Okay, so all variables, all observations are on a specific horizontal line because this is y is ordinal, but still it makes sense to fit the straight line in some case. Of course, it's harder to interpret it. I don't know, maybe this line. So this can be used to predict or fit the data. So we need some interpretation. For example, if the x values is here, then actually, okay, so suppose we have the 5 y values. So this point maybe 2.3. So that may be interpreted as the 2 because this 2.3 is closest to 2. So we need some interpretation, but still sometimes the linear model just fits fine. Yeah, so ordinal response is similar to numeric variables, especially if we have many levels. So in the previous example, the income was predictor, but if we use income as a response variable, it has the 26 levels in the presidential election data. So in such a case, if the income is the response variable, then it makes sense to use that variable as the numeric variable. And the problem is how to compare models. For example, the probit model, the ordinal probit model, and the proportional odds model. So those are likelihood-based methods, and it's very similar models. So we can compare with likelihood ratio. So that is possible. But the linear function, the likelihood assumption is totally different. So it's not really appropriate to compare the likelihood itself. Yeah, so actually it's almost impossible to compare the models, but still there are some ways to compare. For example, we can compare the result by calculating the predicted class for each observation. So as we have seen, if x value is given, then maybe y value is 2.3, but we can interpret as 2. Then we can compare the number of correctly predicted responses. Then we can compare the performance of linear model with the proportional odds model, for example. So in general, the comparing fitted values is a good way to compare totally different models. Yeah. And another consideration is the proportional hazards model. So this comes from the survival models. And the survival models it was originally developed to see the proportion of individuals to die within the certain time period. For example, that we use the so for example, we have the cancer patients with different demographic variables, then we will see how many of the patients survive after 1 year. or more traditionally, that we think about just it estimates the proportion of deaths within a year. So just we pick up the healthy, all people at the age 60, then within 1 year, how many of them die. So that is, center issue in for example, health, the life insurance. So that can be modeled by these survival models. And the concept is we formulate the probability of variable t. This is basically the time of death for individuals. So we deal with this as probability of t is equal to t over probability of t is larger than or equal to t. So the denominator basically includes all individuals which lives at time t at least, and the numerator is just the individuals who die at time t. So t is discretized. So t may be year, but the at least we can see that the probability of survival for in a certain time period. And then the Cook survival model estimates this probability by this formulation. So this is similar to proportional odds model or the ordered probit model. So we have the t term. So t is basically the age. So the age. So this is just depends on t and the exponential of beta transposed x. So x is the predictor values and the beta is always common, and the first part depends on t. Second part does not depend on t. And if we identify this, after that we calculate probability of t is exactly equal to t. And for ordinal response, so ordinal response isn't really the age at death, but we can use it. We can use the response as the age at death. Then we can apply the proportional hazards model. The textbook's explanation of proportional hazards model is kind of weird. So it's just introduced in the middle of the section, and without any examples, they just skip to the another topic. So, but anyway, so this textbook does not discuss this model. So we don't discuss either. But the details of the survival analysis is available on the website, and in our language, we can use the function such as the cox-ph, the proportional hazard model in the library survival. Probably this is the most famous, most popular package for survival analysis in R.